Hey everyone, so on our Instagram page recently, we asked the question about what calcaneal motion will be limited in a client with a certain foot representation. And we're going to show what that foot representation looks like here. But this was a client that had a lot of toe extension available to them, but a significant reduction in toe flexion range of motion. Okay, and we asked how might that influence the availability of motion at the rear foot, specifically through the calcaneus. Okay. Now, the answer to this question was that if a client has a limitation in toe flexion range of motion, that may likely influence the ability of the calcaneus to evert. Okay, and we're going to discuss that here by considering the within foot interactions. Okay, so very often we consider how the tibia, the fibula interact with the foot segment as a whole, but very rarely do we discuss how the rear foot, midfoot, and forefoot all interact with each other. And we're going to do this briefly here and discuss why this may be one out of many potential reasons as to why the calcaneus may lack an ability to access calcaneal eversion. Okay. So if we look at it from a distal to proximal perspective, when we look at toe extension, when the foot is on the ground, when the foot is constrained against the ground, that's important to consider in a closed chain environment. In order for that big toe to extend, the first metatarsal, this bone here, has to plantar flex, okay? And that plantar flexion of the first metatarsal is afforded by the ability of the distal end of the metatarsal to drop, okay, and the proximal end to lift. So this motion here is plantar flexion of the first metatarsal. You can see how that plantar flexion of the first metatarsal will help to encourage a lifting of the medial arch, okay, more of a supination external rotation outwards of the midfoot, and that would oftentimes couple with an inversion of the calcaneus, okay. Whereas toe flexion requires the distal end of the first metatarsal to lift and the proximal end to drop. Okay, that allows for that big toe to flex. That is a dorsiflexion of the first metatarsal. When the proximal end drops, the distal end lifts, that will encourage a dropping of the midfoot. Okay, a lengthening of the medial arch. That will also encourage then a eversion of the calcaneus, because everything is dropping medially where the pressure can shift into the medial portion of the foot. This is why we can look at this as something, if toe flexion is limited, it may influence the ability of that calcaneus to access eversion, okay? Because if we consider the movement behavior of the calcaneus as an isolated segment, if you were to consider this calcaneus as just floating in space without the rest of the foot, without the tibia and the fibula, and consider what direction it turns in, what direction it rotates in, okay? So if I evert the calcaneus, now consider this is the left foot. If I evert the calcaneus, if you consider what direction that's rotating in, it's rotating towards the right, okay? This would be towards the left. This would be towards the right. So if you were to consider that calcaneus spinning, that's rotating towards the midline of the body, which would be an internal rotation of that segment. So a rotation towards the midline is internal rotation. A rotation away from the midline is an external rotation of a segment or a joint. Okay, we're looking at it from a segmental standpoint here. So when that calcaneus everts or internally rotates, it allows for the midfoot, or it affords the ability of the midfoot to pronate, drop medially. It affords the ability of the first metatarsal to dorsiflex, where it drops proximally, lifts distally. That allows for the toe to express some flexion as well. So we can consider this from a proximal to distal and distal to proximal perspective. And this is one out of many potential reasons as to why limitations at the forefoot can influence the availability of motion at the rear foot, specifically through the calcaneus. This is, of course, not the only thing that can influence that motion. We really just wanted to use this question as a reflection of why it may be important to consider what's happening within the foot, between the rear foot, the midfoot, and the forefoot, instead of just considering what's happening at the shin, via the tibia and the fibula relative to the foot as a whole. We can consider how the forefoot, midfoot will influence the segmental behavior at the rear foot. Okay, so hopefully this makes sense. If you have any extra questions, please let us know below.